Okay, dear students, in this session we are going to see the problems on molarity, molality and mole fraction. Continuation of the previous session. What we discussed is relation between molarity, molality and mole fractions. In this session we are going to see the problems. Problem number 1, calculate the mole fraction of benzene in a solution containing 30% by mass of 30% by mass of CCl4 carbon tetrachloride. It's a NCERT model. Okay. Let us see the problem once again. Calculate the mole fraction of benzene in a solution containing 30% by mass of CCl4. Here benzene formula is CH6, carbon tetrachloride formula given CCl4. Okay. Our aim is to find the mole fraction of benzene in this solution when it is along with carbon tetrachloride. Very clearly one information given, 30% by mass of CCl4. What is the meaning of this one? Is nothing but mass of CCl4 in the problem which they are given is 30 grams. Rest of the remaining whatever we say 70 grams is benzene. Therefore, what is the mass of benzene? What is the mass of benzene is 70 grams. Now we are clear. Mass of carbon tetrachloride, mass of benzene, from this point we are very clear. Now we know that what is the molar mass of CCl4, molecular weight of CCl4. It will come 122 grams per mole. Sorry. It is 35.5 into 4 plus 12, 154 grams per mole will come for CCl4. Come to the molecular weight of benzene. What is the molecular weight of benzene? That is 78 grams per mole. We all know about it very well. Now the point is, we have to find separately the number of moles. What is the number of moles of CCl4? Number of moles of CCl4 is weight by molecular weight, that is 30 by 154. What is the number of moles of benzene? That is C6H6, that is weight of benzene is 70 by molecular weight of benzene is 78. If you simplify this one, carbon tetrachloride value, you will get 0.194, while that of benzene you will get 0.897 you will get. So number of moles of benzene is ready, number of moles of carbon tetrachloride is ready. Now we have to find the mole fraction of benzene. What is the mole fraction of benzene formula? Mole fraction of benzene is number of moles of benzene by number of moles of benzene plus number of moles of carbon tetrachloride. Number of moles of benzene we have, that is 0.897 divided by number of moles of benzene, again 0.897 plus number of moles of CCl4, that is 0.194. So if you simplify this one, you will be getting 0.822 as the mole fraction of benzene, which is the aim of this problem. So in this problem what we did is, we have considered what are the components benzene and carbon tetrachloride, and we have separately wrote the data information of carbon tetrachloride and benzene, mass of CCl4 and mass of benzene. Mass of CCl4 from the information we have taken is 30 grams because 30% by mass of CCl4. If they are given 30% by mass in CCl4, the 30% will belongs to benzene. If they give 30% by mass of CCl4, then this will be 30 grams. Benzene is 70 grams. So you can automatically find the molecular weights from the formula. Molecular weights and mass is ready with you. Then you can find number of moles of CCl4, number of moles of benzene separately, and mole fraction of one component benzene we want here from the problem. So the number of moles of benzene by total number of moles of components will be this substitution of that simplification, you will get 0.822. Hope you understand this problem. This is our first problem. Okay. Let us move to the next problem, problem number 2. Let us see the second problem. Yes, it is also one of the NCERT based model problem we have, that is, if 9.55 grams of CuS, cupric sulfide, are dissolved in 500 ml of H2O, 500 ml of H2O. This is the experiment they are given. Then what will be the molarity of CuS in aqueous solution? In aqueous solution is the question, and moreover they are giving molar mass of CuS, that means molecular weight, molar mass of CuS, that is given as 95.5 grams per mole. This is the problem in front of us. Let us observe. In this 9.55 grams of CuS given, they are telling it is dissolved in half liter of water. Then what will be the molarity of CuS in aqueous solution when the CuS molar mass is 95.5 grams per mole? Very clear. We are very clear that what is molarity formula. Molarity formula is weight of number of moles of solute. Solute is CuS. Weight of solute by molecular weight of solute into 1000 by volume of the solution in ml. So weight of solute already given is 9.55. Molecular weight, molar mass of CuS given is 95.5 into 1000 divided by volume of solution in the question is 500 ml. So if you write 500 here, then it will be clear. So 500 into 2 is 1000. So it will cancel 2 times. 9.55 by 95.5 is 1 by 10. So 2 by 10. So your answer is 0.2. Molarity is the answer for the molarity of CuS which is present in this aqueous solution. So this is the NCERT model question we have. Second question on this molarity, we have done it. Let us take down. Okay. Next we will move to the question number 3, problem number 3. Third problem. That is, how much amount of benzoic acid, how much amount of benzoic acid formula given as C6H5COOH. How much amount of benzoic acid is required for preparing 250 ml of 0.15 molarity solution of its methanol, solution of it. Okay, solution they given like this. So how much amount of benzoic acid is required for preparing 250 ml of 0.15 m solution of it? So given something differently, but we will understand the point that is mass of benzoic acid we have to calculate. Benzoic acid formula given is C6H5COOH. So from this formula, if you calculate the molar mass, you will get it is 122. Molar mass of benzoic acid is 122, and molarity given in the question is 0.15, and volume given in the question is 250 ml. So using this all, you can find what is the weight of benzoic acid. First of all, what is molarity? 0.15. Molarity is equals to weight of benzoic acid CH5COOH divided by its molar mass is 122. Molar mass is 122 into 1000 by volume given is 250. So we just have to find this weight of benzoic acid. So weight of benzoic acid CH5COOH will become equals to 0.15 into 122. So this is 4 times cancelled, so by 4 we can write it. This simplification, if you do it, then finally you will get 4.575 grams of benzoic acid. So problem once if you observe, it is the calculation of amount of benzoic acid when the molarity, volume and other things given in the question. So this is the value we got as the final answer for this problem number 3. It is also NCERT model only. Okay. Next we will see the problem number 4. Problem number 4. That is, this is a JEE model problem. This is, let us see, if the density of some lake water, if the density of some lake water is 1.25 grams per ml, 1.25 grams per ml, and it contains 92 grams of Na plus ions per kg of water. So this is the information given to us. The aim of the problem is, question they are giving, what will be the molality what will be the molality of Na plus ions in the lake? This is the question. We all know mass of Na plus given, and we have to find the molality. As you all know that molecular weight means molar mass of Na plus is 23, and mass given for this solute is 92 grams. 23 is grams per mole, and the other things, density given 1.25 grams per ml and all. Okay. So what is exactly molality definition formula? Molality is equals to weight of substance, that is 92, by molecular weight means molar mass is 23 into 1000 by molality is for 1 kg. So we will write 1000 by 1000 only. We will get 92 by 23 is exactly 4 is the molality of the solution. Okay. So what we require to find the molality, that all present in this question, as they are giving per kg here. Per kg means 1000 grams. So 1000 by 1000, we got the answer 4. This is for just confusing you only, density and all. Whenever it is required we can use, now it is not necessary. So then straight away we found the answer. So this is problem number 4. Next we will see the problem number 5. Let us see the problem number 5. Calculate the mass of urea. Urea formula H2NCONH2, they are giving like this. Calculate the mass of urea required in making 2.5 kilograms of 0.25 molal aqueous solution. Question is very clear. In this they are given some mass of solution, 0.25 molality also given, urea is a formula given. So first of all, what we know, that and all we can understand. Molality formula, molality is equals to weight of solute by molecular weight of solute into 1000 by weight of solvent. This is our formula. This WA represents weight of solute, that is urea. So that we don't know exactly in 1 kg how much is there. So if you write separately WA, then it will become molality into molecular weight of urea into molecular weight of weight of water divided by 1000. Aqueous means water only. So molality given in the question is 0.25. Molecular weight of urea is 60 into weight of water, means water is solvent, it will be considered as 1000, as this is for 1 molal only. So 1 kg we are discussing. So 0.25 into 60, we will get 15 grams. So in 1 kg of solution we have 15 grams of urea is there. That is the meaning of this calculation. So what is the meaning of this calculation is 15 grams is solute mass. You want solution mass means what will happen? Therefore, solution mass how much? 1000 grams of solvent plus 15 grams of solute. So 1015 grams means if you want to convert this one into kilograms, you can write 1.015 kilograms. So it is very clear. 1.015 kilograms is the mass of solution. So in this just 15 grams of this what we call solute urea is there. So what is the solution mass? Solution mass is 1.015 kilograms. So in this mass of solution we have urea mass how much is there means 15 grams. But according to the problem they are asking us to calculate the mass of urea present in 2.5 kilograms of solution. So if you write here 2.5 kilograms of solution, we don't know what is the mass of this urea in grams. So just simplify, upon cross multiplication you will get x value. X is equals to 2.5 into 15 by 1.015. If you find the simplification answer, you will get exactly 36.94 grams or approximately 37 grams you can write as the mass of urea which is present in 2.5 kilograms of 0.25 molal aqueous solution. So molality given, but if the mass of solution is increased, then mass of solute also increased. So 15 grams of this urea is present in 1 kg, 1.015 kg. So that will definitely increases when the mass of solution increases is the indication, that is 37 grams of urea. So this is JEE NCERT model question we have in this discussion. So this is problem number 5. Once you can cross check the simplification. Okay, let us move to the next problem, problem number 6. So what is the problem is Norfin. So they are giving its formula is C19H21NO3 is a drug only. So like morphine, Norfin is similar to that of morphine, saying that there is used to combat withdrawal symptoms. In narcotic users. This is one property of this Norfin they are telling. Okay, they are saying dose of Norfin generally given is 1.5 milligrams. What is the general prescription is 1.5 milligrams. They are asking us calculate the mass of 1.5 into 10 to the power of minus 3 molality, small m means molality, aqueous solution required for the above dose, So let us once again observe the question. Up to here its properties and all given. How much generally they are giving is 1.5 milligrams of nalorphine. We have to calculate the mass of this molality solution for the above dose. So here we should be very careful. That means molality meaning given is nothing but 1.5 into 10 to the power of minus 3 molality of this nalorphine solution indicate that this many moles of nalorphine is present in 1 kg. 1 kg means how many grams? 1000 grams of this solution. That is the meaning of this molality. And also we should calculate what is the number of moles, what is the mass of this one. First of all, if you take the simplification of C19H21NO3, converting the moles into mass, how to convert the moles into mass? Mass of this solute is equals to number of moles of solute into molar mass of the solute. Okay. And I have taken the considerations of all the molar masses and I found this number of moles given in this one with its molar mass using this formula as 467 milligrams. 467 milligrams. So what I found is nothing but this moles is converted into milligrams. I found that 467 milligrams of this nalorphine is present in 1000 plus this many grams of the solution. So 1000 plus this milligrams into grams, what is the answer is nothing but 1000.467 grams of solution. Means here what I did is nothing but this 467 converted into milligrams means 0.467 which is added to this solvent mass. Okay, this is the mass of solvent only, solvent. Then I can easily find what is the mass of solution. Mass of solution is mass of solute plus mass of solvent. Solvent mass is 1000 grams, solute mass is 467 milligrams. Total is 1000.467 grams of solution. Let us see what they are asking us is the dose generally given is 1.5 milligrams. For that, what is the mass of the solution? Solution mass we have to find for this dose. What is the dose value is 1.5 mg. 1.5 milligrams which is given in the problem for nalorphine. That time we have to find what is the mass of solution. So we have to find the mass of solution using this 1.5 milligrams of doses. So upon cross multiplication we will get what is the x value. X is equals to 1.5 into 1000.467 divided by 467. Upon simplification you will be getting 3.21 grams. 3.21 grams of solution. So solution mass we found from this simplification. So here what I did is I have just taken the idea of mass of this number of moles of nalorphine and converted that mass of mass into the mass of solution also. Using this mass, using the mass of solvent, I found the mass of solution. But the dose given to person is 1.5. So 1.5, how many grams of solution is required? Solution mass we have calculated using this calculation. So let us see the question number 7. Next question. We will move to the next question. Problem number 7. It's a JEE mains problem. We are going to see now. This previous problem what we discussed is NCERT model question only. You can cross check the NCERT to see the problem clearly. Let us see the next problem. The amount of sugar sugar formula given as C12H22O11. The amount of sugar required to prepare 2 liters of its 0.1 molarity aqueous solution is how much? Options we have already. It is 136.8 grams. Another one given is 34.2 grams. The other one given is 68.4 grams. Other one is given as 17.1 gram. These are the options we have in front of us. Okay, let us see the problem. Amount of sugar required to prepare 2 liters of its 0.1 molarity aqueous solution. We are very clear that what is molarity formula. Molarity is equals to weight of solute divided by molecular weight of solute into 1 by this volume of the solution in liters. So if it is in ml, you will write 1000 here. Okay, because in the question they are given liters, so we are expressing the volume of the solution also in terms of liters. Here amount of sugar, amount means mass of sugar, WA is again the aim of the problem. So if you write WA and if you modify the above expression, it will become WA is equals to M into MA into volume of the solution divided by 1. Molarity of the solution given in the question is 0.1. Molecular weight of sucrose is 342 into volume of the solution given in the question is 2 liters by 1. So upon simplification, you will get 68.4 grams. So 68.4 grams is the right answer for this question. So let us cross check its simplification. Okay. Let us see the next question. Question number 8. This is also a JEE mains type of question, that is 8 grams of NaOH. 8 grams of NaOH is dissolved in 18 grams of water. 18 grams of water is H2O. and also they are giving mole fraction of this NaOH in solution they are giving, they are telling mole fraction of NaOH in this solution, they are asking, and molality means they are not giving, they are asking us mole fraction of NaOH in solution and molality in moles per kilogram of the solution respectively, or means we have to see different things. So they are giving options also. Let us see 0.167 and 22.20, 0.167 and 11.11, 0.2 and 22.20, 0.2 and 11.11. So these are the options they are given for us. So just talking about NaOH, talking about water. So two things if you find, it will be very clear. We have to find the mole fraction of NaOH. What is mole fraction of NaOH? Number of moles of NaOH. So number of moles of NaOH divided by total number of moles of solution. So what is the mass of NaOH? Is 8 grams given. 8 by 40 is the molar mass of NaOH divided by again 8 by 40 plus the other component is water. Mass of water is 18 and molar mass of water is again 18. So 8 by 40 is 1 by 5. We can write 1 by 5 and this is also 1 by 5 plus this is 1. So if you simplify 1 by 5 into 5 by 6, so 1 by 6 will come. 1 by 6 is nothing but 0.167 only. 1 by 6 is 0.167 only. Okay, this is our first answer. So either A or B may be right answer. Let us see second one. What is molality in terms of mole fractions divided by molecular mass? Okay, this is already we have number of moles of solute, that if you write it then you will be getting yes. Why I have taken 18 here is 18 grams of water is given. So what is the number of moles of solute is 1 by 5 into 1000 by 18. So now if you simplify it is 200 times. So 200 by 18, 200 by 18 definitely you will get 11.11. So 0.167, 11.11 is the answer for this question. So here we have utilized this mass of water as mass of solvent to find the answer. Okay, the other way also is there, but in that way if you do it you won't get exact answer, but close to this 11 only you will get. Okay, so let us see the simplification and we'll move to the next problem. Problem number 9. Now see the next problem is also JEE mains model problem. what would be the molality? What would be the molality of 20% mass by mass aqueous solution of potassium iodide? And also they are giving molar mass of Ki. Molar mass of Ki is equals to 166 grams per mole. Options we have 1.51, 1.08, 1.48, 1.35. These are the options we have. Let us carefully observe what is molality of the solution. We have to find the molality of the solution using this mass ideas. Okay, we have Ki is there. Ki is the solute, and this Ki number of moles we can easily find, okay, using mass of Ki. What is 20% means? 20 grams is Ki, rest of the 80 grams is water. So 20 grams is the weight of Ki by its molar mass is 166. This is the number of moles of Ki solute. Come to the other point, molality. When you are writing molality formula, molality is equals to weight of solute by molecular weight of solute into 1000 by weight of solvent. Already we have WA by MA, that is number of moles, is 20 by 166 into 1000 by weight of solvent. Solvent weight is nothing but 100 minus this 20 is 80 grams. So that 80 we will write here. So if you simplify, definitely you will get 1.51 is the molality of this solution. Okay, this is the answer for this question. Next, we'll move to the next problem. This is the last problem of this session. Let us see another JEE mains model we have. The question is, the mole fraction of a solvent, very clearly they are giving solvent mole fraction, solvent in an aqueous solution of a solute is 0.8. So they are very clearly giving mole fraction of solvent is 0.8, means mole fraction of solute is 0.2 only, right? The question is the molality, and that is also in terms of mole per kilogram of aqueous solution, is, we have options are, let us see, 13.88 into 10 to the power of minus 3, 13.88 into 10 to the power of minus 1, 13.88 into 10 to the power of minus 2, another one is 13.88 only, 13.88 only. As we are very clear, when we have a mole fraction of solvent is XB 0.8. Mole fraction of solute definitely will become 1 minus 0.8 is 0.2. And moreover, we know that what is the solution, aqueous solution. For aqueous solution, what is the molecular weight of this water? That is 18. These are there, means we can easily find what is molality. So what is molality formula? Molality is equals to mole fraction of solute into 1000 by mole fraction of solvent into molecular weight of solvent. So what is XA is 0.2. What is XB? 0.8 into 1000 by MB. MB is nothing but molecular weight of water, that is 18. So if you simplify, you get exactly 13.88 is the molality of this aqueous solution. So 13.88 is the right answer for this question. I hope you understand this problem. Okay, we will be seeing several this type of discussions in our coming sessions. Until, have a nice day. Keep subscribing my channel for updates. Thank you.